Let's see, what are we going to talk about? Is there similar triangles in this? I don't think so, it's just congruence. I'm going to talk about both. The camera can hear you. Keep that in mind. Keep it clean. I have no idea if this is in your packet. We're going to talk about it anyway, and then we'll talk about it. What is similarity? No.
No, that's equal.
No, that's congruent. Congruent means the same or equal in every single possible way.
Like.
Similar is like kind of alike. I'm just looking for a specific phrase. Are these similar?
No.
Okay. Are these similar?
Yeah.
Not really.
I would say yes, because there's two of those little guys inside
Okay.
I think a square and a
They don't have the same amount of
diamond would be more
sides.
similar than a diamond and a triangle.
Are those similar?
Yes.
Still no.
No?
No. Absolutely not.
Wait, do they need to be exactly
And it's not really. It's no. Those are
No,
not.
it's exactly the same, but yeah, ratio. They should be,
Ratio.
like, what is this size and what is
Are
this size?
these similar?
Yeah.
Yes. Same shape, different size.
What if you turn the diamond sideways? Wouldn't it be a square?
No, it would be like a parallelogram.
If it was like a, what is, if it was a perfect square diamond though. But that's not a square diamond.
So same shape, different size. What gives polygons their shape?
What's a polygon?
What is a polygon? All right.
Angles.
Is it like four sides?
Or like, not, what is it, vertex?
A polygon is just an enclosed figure with straight sides that I don't have like the book definition.
What is the corner?
Isn't it quadrilateral?
Vertices, vertex, vertex, singular vertices.
What's a quadrilateral?
A quadrilateral is a four-sided polygon. Any polygon with four sides. That is a quadrilateral, that is a quadrilateral, that is a quadrilateral. That is a quadrilateral. Now, what you can build on that and say regular quadrilateral, that would be a square. Regular meaning all the sides are the same and all the angles are the same. A regular pentagon is the one you always picture, where you have like all the sides the same and all the angles the same. That's not. Oh, turned out. Yeah, that one's a little off. Right? That's a pentagon. So is this. 1, 2, 3, 4. Just kidding. That's a hexagon. But it's not a regular. That's a hexagon, and so is that. Nope, that's a pentagon. I'm not doing very good here. How do you drop? Freaking. Oh yeah. Anyway. So those are all polygons, and then the names determine how many sides. Like triangle, three sides. Quadrilateral, quad, four sides. Pentagon is 5. Hex is 6. 7 is hept. 8 is octagon. 9 is nonagon. 10 is decagon. 11, I don't know. I looked it up one time. It's weird, and we never talk about it, and I don't know why we skipped it. That's 12. 12 is dodecagon. And then beyond that, usually we don't even talk about the names. We just say 13gon or 14gon. Because the names, there are names, but we just never learn them.
Wait, so what's the 11 called again?
I don't know. I don't remember. I Googled it one time, and I was like, oh, cool, and then I forgot. So, similar though, same shape, different size. And I said, what gives a polygon its shape? There are two things that give polygons their shape. How many sides there are, and what the angles are. Right? These are the same number of sides, but the angles are all different, so they're not similar. For things to be similar, they need to have the same number of sides and have all the angles the exact same. They can be different sizes. Right? The side lengths can be different. When you're trying to prove things are similar, and usually it's triangles, what do you need to know to prove two triangles are similar? This is the symbol for similarity, right? It's just a little thing like that. Congruence, the symbol is like an equal sign with that thing on top of it. That look familiar? This is rough.
Sort of.
So here.
Don't you know like one side and or two sides?
Not for similarity.
10 that have gone. That's
This is not to scale. Are those triangles similar?
a- Wait,
Yes,
yeah.
How do you know?
because the angles are
It's
the
the
same.
same angle.
30 is the same. 30 plus 40 is 70, so that'd be 110, right? Yes. Do you need to know, well, all three of them need to be the same. But if I just left that blank and said, are those triangles similar, do you know?
Yeah.
Yeah, because if two of them are the same, if I add them up and subtract from 180, won't the third one automatically be the same? So to know two triangles are similar, what's the only thing we really need to know?
Angles.
Two angles. Remember angle similarity?
No.
Yes.
No, okay. There's another way to prove triangles are similar. So if I'm like, this angle's 30 degrees, and this side is 5, and this side is 8, and then in this triangle, this angle's 30 degrees, and this side is 10, and this side is 16. Are they similar? Yes, because of side angle side. Why does that work? Well, if the ratio between the sides is the same, then all of the angles are going to end up being the same. Kind of similar to the reason, like, if I know this angle, like, you might think, well, this angle must be bigger because this side is longer. And it's like, well, no, because this side got longer also. These two sides didn't stay the same. So if everything gets bigger at the same rate, then the angles are going to stay the same. So if I just keep doubling all of the sides, the angles aren't going to change. Because all of the sides are getting bigger at the same rate. So that got multiplied by 2, that got multiplied by 2 also, therefore those angles are just going to stay put. If I just made that side 10 and left that side as 8, well then yeah, all the angles are going to change. But as long as the sides get multiplied by the same thing, they're similar. So that works. And remember this, that's called side angle side. If you know an angle between them and that two sides are proportional, then you have similar triangles. Remember these? Sounding familiar? Do you remember the third one? There's one more for similarity. 2, 3, 4, 10, 15, 20. Are they similar? Yeah, because all of the sides got multiplied by the same thing, so all the angles are going to stay the exact same as the original. So those are similar, and that's side, side, side. And those are the only ways that you can prove triangles are similar, is if you have one of those three conditions. I mean, you could have extra stuff. I can have side, 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 and an angle. Hey, that's great. That's even more proof that they're similar. Because it's side, angle, side, and it's side, side, side. So this is just like the bare minimum. I need to have at least these things. Angles have to be the exact same. The sides don't have to be the same. They just need to go up by the same amount, or be multiplied by the same scale factor, or multiplied by a common ratio. These are all just different ways of saying the same thing. Remember that?
I remember the AA and SAS and SSS, but I don't think I ever even knew what they meant.
Okay, it's just ways of showing that triangles are similar. Congruence, you do the same thing. Angle, angle doesn't work though. Because if I just know two angles are the same, I don't know anything about the sides. Congruent has to be same angles and exactly the same sides. It's the exact same shape. So angle, angle doesn't work. Side angle, side works. I don't really have time to explain why all these work. But like, the only difference with congruence is the sides need to be the same, not multiplied by the same thing. So like if I have 5, 30 degrees, and 7, if the triangles are going to be congruent, this needs to be 5, 30 degrees, and 7. And this has to do with that whole string thing. If I know that side's the same, and I know that side's the same, and I know that angle's the same, that's kind of like, well, if this angle's the exact same, doesn't this side need to be the exact same as that side? It automatically would be. And if that side's the same, and if those sides are the same, then those angles are the same, and if those sides are the same, then those angles are the same, and then they're congruent. So that's just like why this works. Like, if I know one side and one angle and the other side over here, then I know the triangles have to be congruent, just based on what I said. So side angle side works for congruence. You can also have angle side. That's where I know two angles are the same, and I know one of the sides is the same. Because if I know two angles are the same, I know if all three angles are the same. If I know all three angles are the same, and one of the sides is the same, then all of the sides will be the same. So I'll stop explaining. You want me to just list them? We got angle, angle, side, side, angle, side. Side, side, side still works if all three sides are the same. Angle, side, angle. You know the difference between angle, angle, side, and angle, side, angle? The order, yeah. This, so if I know this angle is, well, you know what this means?
They're the same.
They're the same. And that one is the same as that one, and I know that's 10. That's different than see the difference? This one I have two angles next to each other, and then the sides here, it's angle, angle, side. This one I have two angles, and the side in between them is the same. That's angle, side, angle. Either one of those works. If I know those two angles are the same, and I know one of those sides is the same, then I know those triangles are congruent. And the last one, which I never use, is hypotenuse leg. That's just for right triangles only, obviously by hypotenuse. If you got two right triangles, and you know the hypotenuses are the same, and you know one of the legs are the same, because of Pythagorean theorem, you could figure out the third side, and you would know that the third side would have to be the same because of Pythagorean theorem, because you're going to put the same numbers in. So this is basically just side, 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 because if you did Pythagorean theorem, you could get the other side. It's just basically side, side, side for right triangles. They count it as another reason sometimes. There's one that doesn't work, and it's really easy to remember that it doesn't work. Are these triangles congruent? These angles are the same. This side is 5, and this side is 8. You're laughing good, so there's a little bit of memory there.
We don't have enough info, right?
You don't have enough info. That
The
is
side
correct.
side angle doesn't work.
Oh, you don't have to be politically correct here. That's clearly angle, side, side.
Oh.
Don't be a
Oh,
dumb.
I didn't think about that.
Don't be a dumb angle, side, side. That's what I always tell people. If you put that as your answer, you are a dumb angle, side, side. And you will get it wrong every time.
Why
So-
doesn't it work though?
Why doesn't it?
Because there's not enough.
Because we don't know anything about this angle or this side. This side could be 5 and this side could be 8, and I can change this angle and like make it obtuse even while still keeping that angle the same and changing the length of that side only. I used to have a computer thing that would kind of show you, but we don't, this is like crunch time. We don't have time to like sit here and go through it. But it doesn't work. Just don't be a dumb angle side side. If you'd like to explore it further, you can come in after school and we can get into it deep. Okay. So there's the ways you could prove triangles are congruent. So am I going to start connecting to this? Okay.
So, like it's Pythagorean theorem, right?
Yeah, it's just Pythagorean theorem. That's why it works.
Okay.
Hypotenuse leg is just one of them. So let's say you get all kinds of configurations of two triangles, and we'll say, prove how they're congruent. And it'll be like, here's A, B, C, D, and I'll give you that. And what else do we know? I'll give you that. And it'll say, are these triangles congruent? Is A, B, C congruent to D, B, C? And if so, tell me how you know. That's all a proof is just telling how you know.
Yes.
How?
Because the side's the same and
AB
angles are the same.
equals BD.
AB equals BD. How did you know that?
Given.
It was given to you. It's right there. It says this side equals this side.
BC equals BC.
BC equals BC. That's true. There's a name for that.
Reflexive, right?
Reflexive. When it's the exact same side in both triangles,
I'm remembering it. I can feel the
reflexive.
pain already.
You think it's reflect because you're like, oh, hey, it reflect. No, it's not. It's an X. I don't know. If you see that word, it just means it's the exact same side.
Yeah,
That.
it's reflect.
No, it's reflects.
Well, yeah, but then reflexive is like a mirror.
Reflects with a CT. It's a different word.
Oh, really?
Yeah,
Well, I know reflects.
it's a different word. This is reflective. That's
Oh,
like
okay, reflective, that's
when
what
you
I was
sit in your room and you're like, man, why'd she dump me? Reflective about your actions. It's just like, yeah, different word. Okay.
You do your proof for white girls.
Okay, so we got this side's the same, this side's the same. What else? The angle. So that would be angle
C.
No.
CBA?
ACB
DC.
and DCB are the same.
Wait, oh. Okay.
How do you know those are the same?
Because the line has to go 180.
Yeah, something about that has to be 180, so those are supplementary, and that's a right triangle, that's a right angle, so that one has to be a right angle, something like that. Right? Blah, 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 blah. So are they congruent?
Yeah.
Which-
Definition of an
Which
angle
one of
bisect.
these is your reason?
Oh, no, that's ABD.
Side,
Flip it.
It'll
Hypotenuse?
side angle
Says.
side.
Hypotenuse leg?
Hypotenuse leg. It is hypotenuse leg.
Okay.
If you use this angle, you're doing angle side side. That doesn't work. But since that's a right triangle, this is the hypotenuse and this is the leg, the answer would be hypotenuse leg. That was just an accident. That was pretty cool.
Tell me what the thing
Huh?
Does ABC equal CBD?
Not necessarily. You cannot say that those are equal. You don't know anything about why they would
Okay.
be equal. Unless sometimes the problem will tell you, it'll be given, it'll say BC bisects
Okay.
ABD.
Oh, okay.
Or, yeah, it'll say it like that. What does bisect mean?
It splits it equally.
Splits it in two equal parts. So if it tells you that this line segment splits this whole angle into two equal parts, then you would know those are the same. Then you could use side angle side to say that they're congruent. Because then you have two sides and an angle between them. But we didn't have that, that's why we went with hypotenuse leg. So all you're doing on all of these is just trying to figure out what's the same so that you could fit one of these conditions, either if they're similar or congruent. That's all proofs are. And anything more complicated than that, you're still going to pass your ass back. Like, they're not going to get hugely crazy. Let's look in here and see what we got. That is really hard to read.
Number 9? I can read it. I got it. I've been staring at it for the past 10, 15 minutes.
Oh, hey, it's kind of the same as one. What's the first thing? ABCD and isosceles. Ooh, isosceles. What's that mean?
Two equal sides.
Triangle.
2 equal sides and angles.
I don't know
We
this.
learned that diagonal class. Triangle. This is something has two sides. Yeah, we sang a triangle song. We sang
Yeah, we
another
just saw
song.
in 5th grade
Angle.
also. Portland, actually.
Yeah, we did an angle song.
It's a Schoolhouse Rock.
We did that, but also because like
There's another
there
one.
was other ones where he like
I never
legit like
learned
had off of iTunes, and I'm like,
What
why?
was
I
it
just
on
learned
the
the new
phone?
So what's an isosceles triangle? We're running out of time. Let's go.
Okay.
Back up.
Wait, what?
And I saw some triangle, 2 equal sides, 2 equal angles.
Two equal sides.
Collective number.
And because of two equal sides, obviously you're going to have two equal angles. So we know that that has two equal sides somewhere.
It's A, B, and
Prove that angle A equals angle C. Okay. Okay, and on a lot of these, it'll say like, prove these angles are equal, or prove these sides are equal. And I'm going to wait for you because this is an important sentence that I'm about to say. So on every single one of those where it's like, prove these angles are equal, or prove these sides are equal, all you do is, first thing you do is you prove the triangles are congruent, and then you say, hey, If the triangles are congruent, then these sides have to be the same. That's it. If you can prove the triangles are congruent, then obviously these sides are the same. Obviously these angles are the same. So like this one, it says prove angle A equals angle C. The way you do that is just prove that the triangles are the exact same. And then at the end, your conclusion is, oh, because the triangles are the exact same, those angles must be congruent. That's all of the way all of these are. Okay, so let's try to read this.
BD is the angle
Let's first say
bisector of
ABC
angle
is an
B.
isosceles triangle. That's given. So we know two sides are equal. But we don't know which two sides, do we? Aren't. Does that say BD?
Yeah, BD is the angle
Is the
bisector.
angle bisector. So BD is that bisects angle B. What does that tell us? What can we mark? And you should mark up your triangles once you figure stuff out. If that line bisects that angle,
Then those two sides have to be the same, because, well, those two angles have to be the
those
same.
two angles. So that angle and that angle are the same. And the the triangle on the left, the triangle on the right, those two triangles are the same. Or angles are the same. I can't read the next one.
I got it.
Definition of an isosceles.
Equals BC.
BC.
Equals AB.
I must be AB equals BC.
AB.
AB.
It's gotta be.
equals BC.
This side is equal to this side, and the reason was a definition of an isosceles triangle. So right there it tells us which sides are equal. So I know that side and that side are the same. Ooh, see where this is good. ABD equals CBD. Definition of an angle bisector. Yeah, we already marked that. That was like conclusion. Because that was the bisector, then sometimes they'll put that as two steps. So don't let that confuse you. It's just saying, hey, those are the same. Next, BD equals BD.
That's probably A.
No, it's BD
no.
equals BD.
BD.
That's BD. How do we...
Oh.
Reflexive.
If it's the same exact line in both triangles, that's the reflexive property. I don't know if that's even part of the question, but this is just good review. So that's reflexive property.
So we can take out AB.
How do we know that triangle ABD is congruent to the other? How do we know that the two triangles are congruent? Well, we'll go right there.
Side, yeah.
Side, angle, side. Yeah. Because you have this side, an angle, and then this side.
Boom.
That's side, angle, side.
Reflexive properties.
And then, see now, okay, in a proof, I know we're done with this question, but I just want to show you how all these work. So look it, you've proven the triangles are congruent by side, angle, side. Then your last step is always just this. Well, because the triangles are congruent, doesn't angle A have to equal angle C? So that's what this says, angle A equals angle C. And they'll write like CPT, I never remember the order.
CPCT.
All that means is congruent parts of congruent triangles are congruent. Or corresponding parts, sorry. Corresponding parts of congruent triangles are congruent. It just basically means, hey, if you have congruent triangles, frickin' everything's the same. So of course those angles are the same. That's all that means. So to answer this question, reflexive property, vertical angles theorem? No. Reflexive property, side, angle, side.
What's vertical angles?
Vertical angles theorem would just mean vertical angles are equal. So if you had two triangles like this, and you were doing some proof, and you like knew those sides were the same, and you knew those sides were the same, and you needed something else,
Those angles that connect.
those angles are the same, and how do you know that? Because they're vertical angles, or the vertical angles theorem. Yeah. And I think now you should be able to maybe handle these. Or at least try. Does that kind of make sense, I hope? So that's proofs. I mean, that's all there is to it, really. Some of the wording you've got to remember, like vertical angles theorem. And we'll see more.
Is there an AAA for congruent?
Angle, angle, angle? No, that's just similarity. If you know all the angles are the same, the sides could be anything, but so they're similar only.
So 10 on the packet would be not enough information.
10 on the packet of the minute. How are these triangles congruent? You know all all the angles are the same, do you know anything about any of the sides?
No.
No. So therefore, not enough information. If it asked, how are they similar, it would be angle, angle. Okay, try the rest.